Thank you, guys. Really nice welcome. Yeah, looking forward to showing you how you're able to create a transaction on our blockchain. So far, we just got a form, and it would be nice to also be able to submit that and save our data into our blockchain. We're going to do that by creating a transaction, just as we did with when we got our balance from the chain. So we're going to start with an unsigned transaction. We get packed from Kadena client, same as we did earlier. Go to the modules, go to the builder, and want to create execution. Then in there, we need to add our code. And we get that
Real quick, could you zoom in a little bit? It's kind of hard to see it. Yeah. Thank you.
Good enough? I can go even bigger. But...
This is perfect. Thank you.
All right, cool. All right, so we created our types from our smart contract. So what TypeScript does, he knows what modules are available. So hey, it's free.crowdfund. That's exactly the smart contract that we're going to use. Since there's only one, we created our types for. And then inside that, we have our functions. So when we take a look at the contract, you see all these funds, which all are functions we can call. So this one is the one that we need. We want to call create project. And as you can see, there are several arguments that it takes, such as a unique ID, a title, the token we want to raise funds in, the hard cap, soft cap, and so on. So when we add that here, create project, it's just a function we can call. First argument it needs is unique ID. So what I want to do is take that from the form. It's currently not there because we need to add it here. And I'm adding it here so we can use it later as well, because we want to submit our transactions to the blockchain. But we also want to save the project in our Supabase database. So I'm going to give it the ID here, and it's going to be random string from the nano ID package. So now that it's there, I can use the ID here. Second argument will be the title. That's also available on the form. So that's easy. It's the form.title. Next up, we have the token. So with Kadena, you can have multiple tokens on the chain. So the most simple one is KDA, which we're already using in this project. But you can also create your own token and add some value to that, or you can do whatever you want. So we're going to pass literal here, which means that we'll pass it as a string, and then we have coin, which means we're going to use KDA for this. And go to the next one. TypeScript will just help you find the next value you need. Where was I? Oh, next value is the hard cap. So with JavaScript, you always have the issue when you're dealing with numbers that it rounds them, and when you're adding them together, stuff gets weird. Like you get 0,0001. So that's why we need to pass in a packed decimal. We can create one quite easily by doing a new packed number, and that expects a string. We do have the hard cap on the form object. So we get that out of there. And then, one step back. This value from the form, that's just in dollars, as we set it in the form. But what we actually want is we want this number to be converted to KDA, to the amount of dollars that it's worth in the KDA token. So to do that, we can then grab skda, hard cap skda from the composable, use KDA USD. We pass in the form.hardcap. We want to convert that to USD. What did I do wrong? I added too much. So what this returns is the value of our hard cap, but converted to KDA. So we don't need the form. We do need hard cap skda and get the value from that. That value is still a number, so we convert that to a string. And then, so then this spec number is a function from which we can then get spec decimal. This returns an object that looks something like this. So it's a string inside an object, and spec then knows how to handle that. We do the same for the soft cap. So just replace this soft, and then we do the same here. Replace these two soft cap, and then we're on to the next value. Let's see what we have next. It's the start date. There's a function here that are of a const here that has the value of this function. There's also a short explanation here why we need that, because the project can never start in the past. So if the time of the start date is today, if the start date is today, then we want to add 20 minutes from now to make sure that the start date is always in the future. We pass that to a regular JavaScript date, starts at, that's coming from here, and then we're good. The end date is a little bit easier because we don't need to alter that in any way, so we can just get it from the form object. Next value is the project owner. The project owner is a K account, like the same you got when you create your account, something like this. And we pass that along so that when the project succeeds, we can transfer the money from the escrow account, so to say, from the contract. We transfer that to the owner. So when there are enough funds raised, we can transfer the money to the owner that we're giving it here. For this, we want to use the account of the user that has connected his wallet. So we can use account. We can destructure that from the use wallet, composable, and this will be the account that this will be the account of the wallet that's connected to the application. So we pass that along, and we get the value from that. Next one is an interesting one. It's called a guard. And what this does, this will prevent some functions from being called. So we're creating this project, and we want to make sure that only we, as the creator of this project, can do certain things, such as canceling the project or setting it finished or whatever. We don't want anybody to be able to alter this. So to do that, we must have a key set. Key set consists of a public key and a private key. Normally, that's what you probably know as a key set. But in Kadena, you can have a key set as multiple public keys connected to one account. I'll get back to that later. We want to read the key set. We're also importing that from Kadena client. And we can give this any name. Let's give it the name of my key set for now. Oh, I need to transform this to a date. What did I do here? Oh, yeah. Yeah, let's fix this right away. So currently it's complaining that the value can be null, and we don't want that to be. So remove these, and then before we build the transaction, we check if either the soft cap skda or the hard cap skda is null. If it does, we just return. So now we're sure that this has a value. We can also throw an error like shouldn't happen because we already have some validation in our form. But yeah, since TypeScript is complaining, we fix it like this. We do the same for the account because this can theoretically also be null because what if somebody didn't connect his wallet yet? So we also check for account.value to be not null. And show an error if it is null. Right. So far, TypeScript is quite happy with us. So we're continuing. So these are all the arguments we're passing to the create project function. Since we have an execution function in packed, there are also some other things we need to add. Same as we did with getting the balance. Here. We also need some things to pass along with the transaction. I'll start with the key set. Like I said, we need to pass some keys, and these keys will be used as a guard for the functions, so not everybody can alter this project. The first argument here would be the name, which has to be the same as we passed on line 124, which would be my key set. Then there's a predicate function. So with Kadena, there's a possibility that there's one account where there are multiple keys. So there are multiple public keys that can be assigned to a single Kadena account, which is nice because then you can say like, hey, I'm creating this transaction, but not only me needs to sign, but also some other people of the board or some team members or whatever. And here you can pass in how many keys you want. You need how many signatures you need for this transaction to come true. So there are a few defaults like keys all, which kind of says everybody in this key set needs to sign for this transaction. There's keys 1 that says, hey, anybody can sign. I just need one transaction or one signature. And then there's keys 2, which says, hey, I need two signatures for this transaction to succeed. You can also write your own functions here. So you can say, hey, if it's a transaction less than 10 KDA, I only need one signature. If it's more than that, I need 2. And everything above 1,000 KDA, I need everybody to sign. You can create your own functions for this. For now, it doesn't really matter. So we can just say keys all, because in the next argument, we're going to pass our own public key, which we're also going to get from the wallet. That's it in here as the next argument. And this name needs to match with this name, because this is the actual code this is the actual packed code that you're submitting to the chain. And here you're adding the data to the transaction. So you're adding a key set here and reading it again in your packed code. TypeScript is again not happy because public key could be undefined. So let's copy and paste this and make sure we also have a public key. Right, no red lines anymore. Then we add the next thing. We want to add a signer. So we created this transaction and we're saying to the transaction, hey, this person needs to sign. This will also just be our public key, since we are the creator of this transaction and we want to sign this later on. What else do we have? The network ID. So with Kadena, you have mainnet, testnet, and we also have a local development devnet, which is called fast development. So you're developing against fast development, which is running locally on your machine. But if you finished and you want to test it on a more production-like environment, you can pass in testnet 04, because it's the 04 actually comes from the time that it has been restarted. So that's what the 04 comes from. But you can also, in your production ready, you can pass in mainnet 01, and then you're ready for mainnet and can actually be deployed to production. We don't want to do that now, so we set it to fast development. Then we have some metadata we need to set. This includes the chain ID. So this is also the same as has happened with getting the balance. Our contract is deployed on chain 0. And as you can see, we have 20 chains at the moment, and they're 0 indexed, so they start at 0. But for now, our contract has been deployed on chain 0, so that's what we need. Another thing we need is the sender. And this also is our public key value. Sorry, it's our account value. And this indicates who is going to pay the gas. So the transaction costs for this transaction are going to be paid by this account, which is also the same account that we got from the wallet earlier. Then there's one last thing we need to do. We need to create a transaction from this. So let us check what we have now. So we go to the browser, we fill in some details. Category like art, and then we try to publish it so it actually executes our data, our transaction. So what we see is we just get all the functions. But what you actually want to do is create a transaction from this. So we do that by passing create transaction. Very nice name has been added now. And then you can see, when I zoom in, you can see that we actually converted all this data into a transaction that's ready to be sent to the chain. So command is a serialized transaction or serialized string of all the information we added here before. We have a hash, and that hash is generated from this command, and the signatures is still empty. This is undefined because, like I said, there can be multiple signatures needed for a transaction, and we need to know. And in this way, we can know how many signatures there are needed. If we alter the transaction after this command, after this create transaction has been called, then the hash wouldn't match the command anymore. So this would be the last thing you do before you're ready to send the transaction to the chain. With the get balance transaction, you didn't need to sign the transaction because you were only reading from the chain. You were just getting data, and there was no signature needed. You don't need to sign the transaction just to get a balance. But since we're now adding some data to the chain, we need to sign the transaction. And we can get this function sign transaction from the wallet, and then we can pass the unsigned transaction to that. What that returns is a signed transaction, and we need to await that function. First and only argument is the unsigned transaction, and then we're actually almost there. I'm going to move this a bit down and see what the differences are. All right, we get a pop-up from Echo Wallet where it asks us to sign the transaction. You can see the same data here that has been displayed here. You can see the payload. Everything that we put into the transaction is visible here. So here's our title, hard cap, soft cap, start date, it's all there. So you can check if what you're signing is actually what you want to sign. You need to be sure that everything you're pushing to the chain is the right thing. When we're happy with our transaction, we can press confirm, and it will return a signed transaction. So if I put these beneath each other, you can see that the only difference is the SIGs, which are the signatures. So the public key is the same as it is here. So I don't know if you can see that, but it starts with 453. So that's my public key, and this is the signature. So the signature is created from this hash. So if you're for one reason now change the transaction, you do need to sign again because this hash changed. So this signature will not match with the hash anymore. All right. So now this signed transaction can be sent to the chain. For that, we need to create our client. And we call that Kadena client. And we'll import get client from Kadena client. This accepts a function that generates the API URL. So we'll pass it here. And then here you can pass chain ID and network ID. What this does, it will get that information from the transaction we created, and then returns the API URL or the endpoint that we will pass in here. It will interpolate those values into this URL. Since we're on localhost, we'll fill in 001, which is our DevNet environment. It runs on port 8080. This is just the URL that where the packed endpoint is located. Chain web. This would be our network ID. Chain, pass in the chain ID. Chain ID. And then packed. This will create our client. And on this client, there are several functions. So let me, how do I call this? Let me do this first. There are several functions. With the balance, we used dirty read just to read some data from the blockchain. But now we actually want to submit some data. So we're going to use submit. It expects a transaction, which is our signed transaction, because we can only send things to the chain that are signed. So we pass in signed transaction. This returns a request key. And the request key is actually the same as this hash. And that's what you can use to check the transaction on the Explorer. So you can go to the Explorer and then see what's happening with your transaction. You also need that key later on to see if the transaction succeeded. So we must store it in a const, so we can use that to check on our transaction. All right, so far we've submitted our transaction. So we can see if everything worked. Fill in a nice name again. Agree. And then submit, sign again. Oh, I forgot to await it. All right. Again. Publish, sign, and here is our request key, which, as you can see, is the same as the hash from our transaction. All right, so it has been submitted to the chain, but how do we know if it was successful? And it also needs a little bit of time to process. So how can we check if our transaction was actually good, if it was accepted by the chain? We can do that by using Kadena client and then have a poll status function. This function accepts request keys, which is our request key, and then it will start polling the transaction. There's a callback function we can pass, which is called onPoll, and we can make it console log anything every time we check the transaction. So what we can do is create an alert, an info alert that says, hey, I'm polling the transaction. Or wait, what we can also do is request key. So by default, this polls every second. You can also change that to shorter, or it doesn't really matter. And then every second, it will poll the transaction, pull the status from the transaction to see if it actually succeeded. When it did succeed, it will resolve the promise. and we will get a result from that. So now every time polling occurs, we will get an alert, and when it succeeds or fails, it will resolve this promise, and we will get the result in our const poll result. And so after the transaction succeeds, we actually want to save it to our Supabase database as well, because it's easier to access it from like a regular database than from the blockchain. You can also just get it from the chain, but we're also saving a picture URL and other things we don't have in the blockchain, because you don't want to save everything in there. It's not necessary to save every piece of information into the chain. We're going to get the transaction result from the poll result, and that's going to be indexed by request keys. And this is our key from the transaction when we submitted it. TypeScript also helps us here, and we just want to get the result. You can then check if the status from the result from the transaction was successful. Okay, maybe let's do the other way around. It's a failure. We want to show an alert. It's an error. Hey, something went wrong. Please try again. But if the transaction was successful, then we would like to add it to our Supabase database. So for now, let's assume everything was successful and finish the code first before actually checking anything else. All right, there's a function up here that says create project in database. We're going to use that. It's coming from the use projects composable, and it makes it really easy to add our project to our database. I'm just going to rename this DB result for now. Create project in database. It needs a project. This project consists of a lot of mostly the same properties we already added, and they're coming from the form, so we can just restructure that or spread it. Pass that as form. Already has a lot of information in there which we need, like the title, description, image. Everything is already in there, but we do need to alter it a little bit. For example, we need to override the starts at, because we changed that with the function to be sure that it's in the future. So we override the starts at with our new variable created earlier. We need to add an excerpt, which we can just derive from the description, but make it a little bit shorter. So we only get the first, we don't get the first 150 or maybe even 100 characters from there. We also have an image that we added, but that's not in the transaction, not in our blockchain transaction. And there's also a possibility that no image was added, and in that case, we just add a placeholder. My size. So this. The soft cap is also an interesting one, because soft cap in the form that was just in dollars, and we want it as KDA. So the same that we did here, we have the hard cap and the soft cap. Convert that to a string, so accept it, and the same goes for the hard cap. Last thing we want to add is our request key. So we know that the project in the database, what the request key in the blockchain was for that. This. All right, so now we have all the information. The last thing we want to do is redirect to the page of our newly created project when everything was successful. And what this returns is an object where it has a unique ID. This is the ID that gets generated when saving to Supabase, and that's also the ID that's used in the URL when we check out some project. So here at the top, this is the unique ID that we will use. So we get that from the promise, from resolve promise, and then we can navigate to projects, and then ID. All right, let's see if everything works. Can create a new project. Confirm this. So now it's polling the transaction. We can see that in the network tab. So every second it will check if the transaction is already succeeded or failed. And here we have it. It's a success. So write succeeded. We wrote successfully to the chain. For some reason, I used ID, and I think it needs project ID from the top of my head. Let me check that. Not here. I think it was project ID. I cannot find it right now. Yeah, it was project ID. All right, let's go back here. Rename this to project ID. And then in the form as well. Oh, we should be good. No errors. Let's try again. Let's sign our transaction again. And here we go. So right now the response is empty. And here it is. Success again. Redirected to our new UUID. I think I only made a mistake in the placeholder URL. But that's just a minority. What does it need to be? Oh yeah, need to change that into this. All right, one final go, and then everything should be, oh, it was logged out. Publish, sign the transaction. You can see our request key. There we are, with a nice placeholder image. Got a description here. And this information is now coming from Supabase, but in the same time, we know that it's also saved in the blockchain. I think that's it. Yeah, let me know if you have any questions. Just shoot a question on Discord. Good luck. Hope you
we definitely have a couple questions.
You do?
Yes. Let's see. Do you have any experience working with any other blockchain technology via JavaScript? What sets Kadena apart?
Yeah, I do have some experience. Let me try to focus my webcam. Yeah, there we are. I do have some experience with Solana. And what I think that sets Kadena apart is that it's, for me, I think it's a little bit easier to create a transaction. In Solana, there are multiple ways to create a transaction. And I think when you get used to it, it's easy. But what we're trying to do here with the client, just make it as easy as possible. Like there's only one or two ways to create a transaction. You don't have a serialized transaction or whatever name they call it. So we try to make it easier. And of course, for more power users, there will always be tools where you can, when you're an experienced user, you can, make it as difficult as you want, or you have a certain use case. But in the basics, we try to make it very easy without too much hassle.
Very cool. Thank you. And what's it like building on the blockchain full time?
It's been fun. Yeah, I've been working with Kadena since October, so almost a year now. And I did have some experience with blockchain in general, but more trading and not actually working on a blockchain. And I must say that I learned a lot. It's very cool to keep on learning. And every time, for example, when I looked at Doug yesterday, I just kept learning. Every time somebody gives a talk or something, or just keep on working on a regular basis, you learn new stuff, and it's really nice. And also like that we all don't know where we're going with blockchain. I think it's very valuable, but it could also happen that nobody likes it, or we find something else that works better. But I really like that we're ahead of the curve, so to say. So it's all quite new, and it's really nice to work with all these nice new technologies. It's new stuff is always shiny and nice, so that's cool.
Very cool. And I think that brings great to this next question of like, what do you think is the hardest part to work with Web3 in your opinion?
It's a good one. I think once you wrap your head around just the idea of Web3, which like I think somebody in the comments already said that Web3 is it's a weird name. Like we all know the web, but why do we need a new Web3 name? Like it's just the web keeps on evolving and there's new stuff being added every day. And this just happened to be a big step, so to say. But if you wrap your head around just everything as a transaction, I think that's the hardest part. How do I explain this? It's not that hard if you just see it as a transaction. So everything you do is a transaction, and it needs some time to settle, and I think that's a different thing than just a regular database where you just push it and in a few milliseconds you get a response. And you kind of need to learn that it takes a little bit longer. And if you're used to that, then I think you're good. I don't think there are any. Yeah, like I said, you need to wrap your head around the idea, but actually working with it isn't that hard when you grasp the idea of it. Yeah.
I felt like that's a great part and segue into what's one misconception about Web3 that you've heard, and why do you think it's invalid?
It's like I said, people almost always think it's really hard and it's really different from what you're already doing. And another thing I always hear is you need to switch from Web 2 to Web 3. But as we see in this Vue Forge, we can have them both at the same time. We pick the best parts of both worlds, and you can bring them together. So you don't need to build something specifically on Web 3 or specifically on blockchain. You can just pick the part you need from each web. So the Web 2 or Web 3, so to say. You don't need to have everything on one specific web. I think that's a big misconception.
I like that. We talked about that during the panel as well a bit too.
Yeah.
Last question for you. Are there any other resources available for us to look at if they wanted to integrate Kadena with their Vue.js project?
Yeah, we're currently revamping the complete docs page. So currently it's docs.kadena.io, and there's already alpha build on alpha-docs.kadena.io. But that's more the general docs. Like, we try to get everything in there on a more centralized page where not only JavaScript documentation, but everything lives. But another good starting point would be the README of the Kadena client. Eduardo did a great job on commenting a lot of code in their README recently. So that would be a good starting point from a JavaScript developer's point of view.
Very cool. Thank you. And thank you for all of the answers and going through this today. We greatly appreciate it.
You're welcome.